Let's see if there are any questions. I guess there, or any comment or curiosity. The University of Valladolid, at the School of Telecommunications, Albano Carrera. My name is Albano Carrera. You've said that you use orders of 4 figures for the control of the servers. And my question is, this is a curiosity, technical curiosity. Do you need to be so precise, so accurate? Or could this be obtained with the servers that you're already using? That's all. Well, we don't need to be so accurate. In fact, what we talked about first today was how to minimize the complexity of the problem by having been less accurate. We could have less complexity even more if there was less accuracy in the servers, and that would not affect, I think, the whole movement. Any other questions? Just a reflection on what you said and on the work that you've just presented. I think it has more than one common point with Flavio's presentation. I think the aim is to have an empowerment, a better relationship between the machine and the person. You talked about genetic algorithms with a direct application, so that a person that for any reason is not able to walk anymore can use this machine and learn, and that there is a learning process in which both the robot has to learn from the user about how the user injects the orders into the system, but also the user has to adapt to how the system responds. And in this process of constant improvement is in what we are.
Well, thank you very much, dear Professor Teodiano Freire, for your presentation. And now we are going to give the floor to the public, to the audience. Are there any questions? Well, Ramón de la Rosas, Valladolid University. Well, I found this presentation particularly interesting because we are working in the use of wheelchairs activated through blinking and different uses of the PC. And I was curious to hear, you've heard that you use electromyograms wirelessly. And I was wondering, what use do you give it? How do you work with this electromyograms? That's basically my question, because we use it with a wire for connecting it to the computer, and we convey digitalized data. The PC processes this in real time and then moves a ball. And with these 2 channels, the real time is noticed. It's only been a few years ago that now this work and flows properly. So how do you use these electromyograms? Basically, before trying to answer your question or the beginning of a question, the wheelchair that we have developed is commanded through blinking of your eyes, so that you capture the signal. Then the fatigue also is a very serious problem, because a person in the morning has lots of energy, but at the end of the afternoon the energy is not there. So how can we detect this, whether it's valid or not? And we use neuron networks to detect the signals, and the entry parameters are the energy of the signal. For this we have a parameter and the width of the and the width of the signal, to avoid also the problem of blinking caused by an accident, something that is introduced in your eyes. And also, we also take into account the lubrication necessary in your eyes so that lubrication does not generate a signal. So it's just the blinker of one eye which is considered in. So we have gone beyond, and the whole signal is then transmitted to the PC by Bluetooth, and then we use a filter to make sure that the signal is valid, to eliminate noise. We also have a peak, besides what happens in the first signal. The advantage is that the signal is then generated to the PC so that it processes the signal, the whole signal, and then generates a command. All this is done very rapidly because if I speak about the neural networks that we use in the wheelchair, it's part of the processing. It's not so much part of the chair because you blink and it moves the chair. By blinking, you get one thing. If you blink twice, then the chair starts moving, and even if it takes 1 second to process the signal, the chair keeps moving. This is something that we have tested, and we have a 99.6% success rate, even in various moments of the day, in order to take into account the inherent fatigue. So what we do is take the energy, but we need to also work on these details to make sure that the system is robust. And all this is done wirelessly, and that's something that we need to ensure because, of course, cables are a problem. I have a question for Teodiano, which has to do with the selection of the tasks that you suggest for the children, because if we remember the rate of dropouts of the experiment, children who were not able to use the virtual environment, what criteria did you choose to select the virtual tasks and then the physical tasks, which is the phases where you have had probably more motivation from the children? Yes, I've been working for 10 years with mobile robotics. And so I did experiments in the lab, and then the control works and the errors are measured, etc. The problem is reality. When you do tests and experiments with people, then things change because you need to contact a rehabilitation center. You need to I need to speak with the ethics committee. I need to be introduced to children. I explain to the physiotherapists, so people who work with the children, listen, my system works like this, like this, like this, and I show them how it works. And I would like to introduce to me possible candidates' children who could benefit from this system. And then she gives me a list, an enormous list of children. The whole state of Espírito Santo has children there. And then I start selecting this one, yes, this one, no, and this one, perhaps. And then out of the 32 who came for the initial tests, a number are chosen. And they are brought to us by the psychologist or the physiotherapist. Very often, the physiotherapist then realized that the child would not be good for the experiment, but since the parents had been contacted, it was impossible to say no. And the problem is with spasms. Some of the movements were controlled, but then there was spasms, and then another spasm, and then of course the system doesn't work with this. And the criteria that we used was to use the experience that we have with the wheelchair. The wheelchair we tried with people with cerebral palsy, with myotrophic lateral MS, with Duchenne muscular dystrophia. We had a bit of experience in selecting the children, and we were always accompanied by the special education teacher who helped us decide what children to choose. And you saw that out of the 14 that participated in the process, in some experiments you only had 6. Very rarely did the 14 manage to do things in such a way that we could show you here. Or they did manage to obtain some results, but poor results, but not good enough for the study. For the study, we chose whatever would help us achieve our objective, that is, work with the teachers and then use this for literature. So mainly Canadian people. There's few others who work with this in the world.